Welcome, guys. Welcome, Lynn.
Hello.
Okay. Let's just move on. Share my screen. I was talking about IN here. For today's math class, we'll be talking about motion due to gravity. It's some of you guys are already very familiar with this topic. We already know that the acceleration due to gravity, G, is always acting downwards, right? The acceleration due to gravity is G and it's always acting downwards. And in mathematics, we always approximate this to 10 meters per second squared. I want you guys, I know in physics, those who study physics, we use 9.8, but in your math paper, it's always going to be 10. Okay, so you don't, if you use a different value, you'll get your answers wrong. Okay, so always approximate it to 10. Take G to be 10. Always, and it's always downwards. Remember, sometimes in solving a problem, you may use -10. Sometimes you will use +10. It depends on which direction you choose as positive. Okay, if you choose downwards as positive, then it will be +10. If you choose upwards as positive, then your G will be -10. Okay? And then every other problem remains the same. So you'll still be using your SUVAT equations, SUVAT equations. You'll still be using these to solve problems. So always remember that if, say, you throw an object in the air, let's say it is thrown up with some speed, u, and you are asked to find, say, the time it comes back here. So you will use your SUVAT equations. When it comes back to this point, your S is 0. Your U remains whatever you had there. We are not interested in V, the speed with which it comes back here. We are not interested in V, but we can find V. We can look for this. Your acceleration, in this case, I will choose upwards as positive because my U, I choose my U to be positive. I use U to be positive here, so I choose upwards as positive. So my acceleration will be -10. And T, I don't know. So you use the equations of motion to find whatever you are looking for. So if an object is near the surface of the earth, if an object is near the surface of the earth, we have talked about this before. If this is, say, the earth, and an object is here, the earth will pull this object with a force. And from Newton's second law of motion, if this object is left to accelerate, it will accelerate with an acceleration g, as we have already seen. The acceleration due to gravity is g. And all objects will have this acceleration near the surface of the earth. So from Newton's second law, summation F equal ma, this means that this force, let's call the force Fg, the force due to gravity. So it means that Fg should be m and a is g, is mg, and the direction is always towards the surface of the earth. And this force is the weight of the object. So this is how we got to define weight as mg. We always use mg, so you should be able to understand that it comes from Newton's second law, F equal ma, or summation F equal ma. For those of you guys who study physics, you will have some activities in which you will be asked to maybe explain why does every object accelerate with g, yet if you drop, why does every object accelerate with an acceleration g, even though the masses would be different? So if you drop, say, a stone, let's say you drop a rock, and a feather. A feather is like the feather of a chicken, the wings of a chicken. You drop them, you realize that this one will touch the ground first. But we say that they have the same acceleration. So in physics, you will be asked these kind of questions. And the reasoning would be that the feather has some air resistance, so its acceleration will be less. But if you drop these two things on the moon, if it was, say, on the moon where there is no air, then air resistance will be zero. They will fall at the same time. So I have included a couple of videos in the class, in the lesson for today, so you can just get a deeper understanding of acceleration due to gravity. So I will move straight to 2C and solve some problems there. Question 1 says, find the weight of a man of mass 70 kilograms. Weight is what? Mg. So it's 700 newtons. You see that in real life, sometimes you go and stand on a scale in the hospital and they tell you that your weight is 70 kilograms. Actually, what they say is that your mass is 70 kilograms, not your weight, right? The weight, which is the force, technically, in real terms, the weight, which is the force due to gravity, is your mass times your g. And if your mass is 70 kilograms, then your weight should be about 700 newtons. Let's look at more problems. More problems. Let's look at question 3. I highlighted that already. Question 3. The ball is dropped from a height of 20 meters. We are asked to find the time taken to hit the ground. So we can make a sketch. Sketches are always important. It is dropped from a height of 20 meters. You need to find the time it takes to reach the floor. Remember, the mass of the ball does not matter because the acceleration due to gravity is considered to be the same for all objects. So in this case, your U, the ball is dropped, so U should be 0. It is released, okay? And your S is what? We should take our downward direction as positive. Let's take downward as positive. So your S should be 20. Your acceleration is what? Is 10. Since we have taken downwards direction as positive, right? Now, usually many students get confused with this with these questions that involve moving in under gravity. They always get confused why sometimes I take negative for something and positive for some other times. It all depends on you. If you choose, say you choose upward direction as positive in this case, then this quantity will be negative because it is falling to the negative direction, right? And this quantity will also be negative. Then all your calculations will give you the same thing. If you are asked to calculate, say, the speed, the velocity with which it hits the ground, your velocity will be negative in that case. But since I choose positive for downward direction, if I find my velocity with which it hits the floor, it will be positive because the direction of the velocity will be downwards. Okay, so we are asked to look for T. Which equation should we use here? Which equation should we use? Where are they? I cannot find anyone. Where are you guys? Anna. Which equation should we use there?
S equal 2t plus
S equal
2t ut plus
ut plus
1/2 a
t squared. Yes. That gives us 20. I always like to do it like that. Since u is 0, this gives us 0. So we get 20 is equal to 5t squared. And so your t should be plus or minus square root of 4. So it's plus or minus 2, right? Now, remember yesterday how I told you guys that in most cases, in 90% of the cases, you have problems to solve. To look for t from s equal ut plus half at squared, you will have one value positive and one value negative. You will always ignore the negative value if it's t, because t cannot be negative. You can never have a negative time. All right? So it will always be the positive value. Okay. Let's solve another problem. Question 6. I highlighted that also. I see it's a little bit. I highlight the problems that I know introduce some, maybe some new idea. We are told that a wrecking ball of mass 1 ton is dropped onto a concrete surface. To crack it, it needs to strike the ground at 5 meters per second to cause a crack. Find the minimum height from which it must be dropped. This mass here is just to confuse you. Mass has nothing to do with the problem. But if you like, just take it out. Mass is 1 ton, which is 1,000 kilograms. So no need to belabor it when we know it's not useful for us. It said that it is dropped, so U is 0. First, let me sketch my problem. This is the wrecking ball. It's dropped. It has to drop to here. Choose direction. I'll choose my downward direction as positive. So U is 0. It strikes the ground, and it strikes the ground with a velocity here, V is 5 meters per second. Okay, I've noticed we just use the number. V is 5. And we are asked to find the height. S, we don't know. What else do we know in this problem? A is 10. Since we choose downwards direction as positive, it means acceleration, G is positive. So which equation should we use here? Ruby. Which equation should we use, Ruby?
V squared equal to U squared plus 2AS.
V squared equal U squared plus 2AS. Perfect. So we'll have V squared equal, this is 0, equal 2 times 10 . We are looking for, what is our V? 2, let me see. Excuse me. So we are looking for S. So 25 should be 2 times 10 times S. So S will be 25 over 20. So that's the minimum height from which it is going to be dropped. Let us go and look at the problem again, interpret it again carefully. Why does it say minimum height, not just height from which it should be dropped? Because the problem says it will need to be dropped to cause a crack. And if it is dropped with this velocity, it will cause the crack. If it is dropped with a higher velocity than this, it will also cause a crack, right? So this is the minimum velocity with which it needs to hit the floor to cause the crack. That's why it asks for minimum height here. So what we are looking for here is minimum height. But if the height is greater, it will fall with a higher velocity. It will also cause a crack. Okay. Let's look at one more problem. And then maybe I'll give you guys time to work on other problems. Let's look at 11. Essentially, all the problems are almost the same thing. It's the same ideas. If you master your Sivat equations, then mechanics is done for you. Anna.
Yes.
And Ruby. Now you must be finding further mechanics to be not so hard, right? You guys were saying it's very hard, but now you see that there are just some basic things you need to know, and then you can extend them. A feather of mass, 10 grams, falls from rest from a height of 3 meters and takes 2 seconds to hit the ground. This is what we were talking about. You're asked to find the air resistance on the feather. So, the acceleration of the feather now will not be 10 any longer, right? So the feather falls from a height of 3 meters. It falls from a height of 3 meters. And it takes 2 seconds to reach the ground. We need to look for the acceleration of the feather, and then we will use Newton's second law to find the forces on the feather, or to find the air resistance. So the first part is this: we look for the acceleration. What is the acceleration of the feather? So we know U is 0. It falls from rest, so U is 0. And S is 3. T is 2. T is given, S is given. And we need to look for A. Which equation should we use here to look for A? Who is this, Floria? Floria. This is Floria, right?
Yes.
Which equation should we use?
U equals S equals ut plus
Just
1
ignore
over 2.
ut plus half at squared. Perfect. Just substitute the quantities and you are done. This is 0 since u is 0. So we get, I will just look for my a directly. So a will be 2s over t squared. That is 2 times 3, which is 6 over 4. 3 over 2. So the acceleration of the feather is 1.5. This acceleration is 1.5. Now, the second part of the problem, we need to look for air resistance. So it means that as the feather is falling, it has a force, its weight. Its weight is mg, and the mass is 10 grams. 10 grams is the same as what? 0.01 kilogram, right? Do it. So the force, the weight of the feather is 0.01 times 10 newtons, right? And then it has air resistance. Let's just call air resistance Fa. And then, in addition to that, it has acceleration of 1.5. 1.5. So we now use our Newton's second law. Summation F is equal to ma. This means that this force here is 0.1 Newton. So this means that 0.1 minus Fa is equal to the mass of the feather, which is 0.01, times the acceleration of the feather, 1.5, right? So that gives you Fa to be 0.1 minus 0.01 times 1.5. Can someone calculate that for me?
0.085.
0.085
Yes.
newtons. So that is the air resistance on the feather. So this problem, this is the reason I chose it, because it introduces the idea of working from one part, important part of mechanics. The two most important parts of mechanics we have studied now are this part. I can assure you this is actually the most important in the whole of mechanics, Savart equations. And the second part we have studied is Newton's second law, how to use it, even though it's a very simple equation, but it's very powerful and very useful in the whole of mechanics. So this question combined the two parts. Does somebody have a question? We have less than 10 minutes left. Is there any question? Nobody has a question.
Okay, so question 16.
Very good. Yeah. I hope we have time to look at question 16. I did highlight but question 15, but since you prefer 16,
16.
16?
Yes.
Yeah. I like it when you guys choose problems to solve like this. This is this question I have here, which I forgot to look at, is a past paper question. But we will look at question 16 first. And if we have time, we'll look at that one. So we are told that a pebble is dropped from rest into a deep well. At time t later, it splashes into the water at the bottom of the well. Sound travels at 340 meters per second and is heard at the top of the well 5 seconds after the pebble was released. We are asked to find the depth of the well. That's an interesting question. It's a two-part question. So I make a sketch. It is dropped into the deep well. It goes down and hits the bottom of the well. And then when it hits the bottom of the well, a sound wave is released. This sound now travels up and is heard here 5 seconds after the pebble was released. You see, this problem is similar to a problem we looked at a while back. The distance traveled by sound is the same as the distance traveled by the pebble. All right?
Yes.
So I'm not going to even draw this diagram. It's pointless. The distance traveled by sound, S, is the speed of sound, 340. Call this H. 340 times times the time it takes. So the total time from here to here is 5, right? If we call this time, say, no, we should not use time. We should use H in that case, since it is H we are looking for. Let's say the time that this sound wave leaves from here and moves up to here, let's call the time capital T. It means that H should be equal to 340 times T, right? So T will be 340 divided by H, correct? And then we will go for the pebble now. When the pebble falls, we know that U is 0. And then T. What is T? We will put it in terms of H. So T is 5 seconds minus this time, right? Minus 340 divided by H. I just put it in terms of H because we are asked to find H. That's what we are looking for. So we can look for it directly. And then we know that the acceleration is 10. Oh, remember that this object was not falling in water, so the acceleration is still 10. It's falling in air, because the problem says that it splashes into the water at the bottom of the well, so there is water here. So it's falling in air, so your A is 10. All right? And then what else do we know here? Nothing else. Let's use S. S is H. So which equation of motion can we use here? S is equal to ut plus half at squared, right? U is 0. U is 0, so ut is 0. So we will have H is equal to 5 times 5 minus 340 over H squared. This is an equation in terms of H. And you can solve this equation to look for H in whatever way you want to solve it. All right? I will not solve this equation because it will take me some time to solve it. First, you have to square it and it will form a quadratic equation. It will actually form a cubic equation in terms of H. All right? But you solve this equation, you will get H. Are we okay there?
Already solved that.
You already solved it? You have another way to solve the problem? Because I know you guys always have some very creative ways to solve the problems.
I think it's similar.
The method you use is similar?
Yes.
Okay. If the reasoning is the same, then it's the same method. The reasoning. Remember, in mechanics, if you sketch a problem, if you draw a diagram of your problem, then your problem is 50% solved. Okay? Diagram. Okay? if a problem is complicated, use a diagram to simplify it. And when you draw a diagram, your problem will always be like 50% solved. Always, your problem is 50% solved if you draw a diagram. You don't need to spend time making you are not doing art, so you don't need to draw something perfect. Just make a sketch of what the problem looks like. Okay, for the rest of the time, I want us to look at this past paper question. Excuse me. Past paper question. We are told that a particle is projected vertically upwards with speed 7 meters per second from a point on the ground. So from a point on the ground, the particle is projected upward. And the speed with which it is projected here is 7 meters per second. You are asked to find the speed of the particle and its distance above the ground 4 seconds, 0.4 seconds later. When it's 0.4 seconds later, what is the speed here? And you are also asked to find what is the height. Yeah. That's easy to solve, right? Now we will consider our upward direction as positive since the particle is going up. It makes sense to consider upward direction as positive. So U is 7. V is what we are looking for. T is 0.4. What else? A is what?
-10.
-10. I'm happy to hear that. So which equation should we use here? V equal U plus AT. So that should give you 7 minus 4. 3 meters per second. That was easy to solve. Next, we are asked to look for, it's not finished, we are asked to look for the distance above. So it's the same thing. U is 7. T again is the same, 0.4. A is -10. And S is what we are looking for. Which equation do we use here? S equal UT plus half AT squared. Now, I will make a note here. Some students, like when I give such a problem for practice to some students, what they would do is, after they look for this value here, instead of using this T, they will use this V here so that they can use the other equation, V squared equal U squared plus 2AS. So they will use V here as 3. The problem with that is that there is no problem, but if you had made a mistake, if there was a mistake here and this value was wrong, then you will have your final answer here will be wrong, and you will lose your accuracy mark here, okay? So I would prefer you always use the original values, except in cases where you cannot use them. So that gives your S to be 7 times 0.4 minus 5 times 0.4 squared. What do you get, please? Did somebody calculate that? Use calculator. I really want to calculate it. 7 times 0.4. 7 times 0.4 minus 5 times 0.4 squared. I get 2. So that gives me 2 meters. Why did I choose to give this problem? I choose this problem because of the second part. The second part of this problem is a little bit tricky. You are asked to find the distance traveled by the particle 0.9 seconds after projection. Distance traveled. You cannot just use this equation to find the distance traveled because this equation gives you the displacement. And it's possible that the particle probably has gone up to its maximum point and is coming down. And then this is 0.9 seconds later, it is here. If the particle is on its way down 0.9 seconds later, then if you use the equation S equal ut plus half at squared, you are only going to get this displacement. Okay, this value here. Okay? But the question asks us to look for the distance, meaning we should look for this and this. But we are not sure if 0.9 seconds later the particle is on its way up, then it's okay to just look for this displacement directly. If it's on its way up, then we can look for this displacement directly. But if 0.9 seconds later is after its maximum height, then we need to look for the maximum height plus this. All right? So the first thing you have to do is find the time it takes to reach the maximum height. So U is 7, A is minus 10, and then V is 0. At the maximum height, V is 0. The speed is 0, or the velocity is 0, so that it can then come back down. And what are we looking for? T, we don't know. We need to look for this time and then compare the time. If the time is bigger than 0.9, then we know that 0.9 seconds later, it is still going up. If the time is smaller than 0.9, then we know that 0.9 seconds later, the particle has already reached its maximum height and is coming down. All right? So which equation do we use to look for t? V equal u plus at. So this means 0 should be 7 minus 10t. That gives us t to be 0.7 seconds. So like we suspected, it will reach its maximum height 0.7 seconds later, meaning that 0.9 seconds later, it is on its way down. So we need to first calculate the maximum height. What time is it? Okay, we still have 1 minute. We need to find the maximum height. You guys can find, right? U is 7, A is minus 10, V is 0, S is what you are looking for, which is the maximum height. Use the equation V squared equal U squared plus 2AS to look for the maximum height. And then after you look for the maximum height, you can then look for this other height. You can look for this other one. This one will also be very straightforward. U is 7. You don't know V. A is negative 10. What else are you looking for? S, you don't know. And T is 0.9. So you look for S. So you use the equation S equal UT plus half AT squared to look for this height. And then you take this maximum height minus this height, and then take the maximum height plus whatever you have there, right? So you need to take the maximum height plus this height, and this height is maximum height minus what you have here. Or you could still find another way to look for this height. You could still look for this one by using U equals 0. S is what you are looking for. A is 10. S is what you are looking for. A is 10. What else do you need here? You don't know T. Oh, T is 0.2, right? Because 0.7 seconds is here, and then 0.2 seconds it should come here, right? So you can look for that height directly as well. Anyway, this is what I just wanted to explain on that. When you read a problem, be careful when it says distance and when it says displacement. Take note of the difference between distance and displacement. In the equations of motion, always S is displacement, never distance. It is only distance if an object is moving in a straight line and it's not moving back and forth, all right? If it's just moving forward, if it's just one straight line and moves from origin to the final point, then the distance and the displacement will be the same. All right? Okay, you guys should solve the rest of the problems on in 2C and submit today. And if you have time, you also go on the course and study, watch some of the videos, but there are some other examples there, but it's not too necessary. You can just solve the problems in 2C and submit. Okay, and then make sure that you mark complete. Make sure you mark complete. Make sure you come here and mark complete for this part, lesson 3. Oh, and lesson 4. Because lesson 5, which will be next week, we'll have some really important things to talk about. So I'll upload some very good videos there for you guys to watch. Okay? See you guys next week. Thank you.